Welcome to aminacademy.com. In mathematical economics, let us discuss about differentials. What is differential? The derivative of a function can often be used to approximate certain function values with surprising degrees of accuracy. To do this, the concept of the differential of the independent variables and the independent variable must be introduced. The definition of the derivative of a function y equal to f of x is equal, that is f dash of x equal to limit delta x tends 0 f of x plus delta x, f of x plus delta x minus f of x, this change in x values divided by delta x. That means here this is the definition of differentials of a function. Now consider a function y equal four x cubed plus 3x squared minus 5. The differential of y is found by the first taking derivatives. Now dy by dx equal 12x squared plus 6x. Now therefore differential is equal to differential of y. Differential of y is dy equal 12x squared 6x into dx. Now on one function, example, y equal 3x plus y plus square. What is dy by dx equal to 3x into 5 or 1 into derivative of 3x, inner derivative is 3, which is equal 6 into 3x plus 5. Therefore differential y is equal 6 into 3x plus 5 dx. Next one, total and partial differentials. The total of a multivariable, the total differential of a multivariable function is used in case where one input variable can affect the outcome both independently and through its effect on another input variable. It is effective for finding the total change in the value of input for a small change in the value of input variables. Here, look at here. Consider the function z equal f of x comma y. That means the function f is having two variable function, that is equal z. The total differential dz is, that is dz equal zx dx plus zy dy. What it means? Look at here. Zx means partial derivative of z with respect to x, that multiplied with dx, plus zy is the partial derivative of with respect to y and multiply with dy. This gives total differential of z function. Now look at one example to understand this concept easily. Look at here. Now z example z equal x power 4 plus 8xy plus 3y cube. Now you have to find the total differential. First, zx. We know partial derivative of this function x is that x power 4 is 4x cube. 8xy is y is a treated constant, so 8y. 8xy derivative is 8y. Then 3y cube derivative is 0. Now similarly zy partial derivative with respect to y is here x power 4 here treated as constant, so it's 0. 8xy is 8x plus 9y squared. Now the total differential of z is dz equal zx is 4x cube plus 8y with dx plus 8x plus 9y squared dy. This is a total differential of z. Next one, partial differential measures the change in the independent variable of a multivariable function resulting from small change in one of the independent variable and assumes the other independent variable are constant. This is a partial differential. For example, this is dz is equal zx dx. Partial derivative differential with respect to x. Next one, total derivatives. What is total derivatives? In mathematics, the total derivative of a function f at a point is the best linear approximation near this point of function with respect to its arguments. Unlike partial derivatives, the total derivatives approximates the function with respect to all of its arguments, not just a single one. Yeah. Suppose this consider the function z is f of x comma y, and y is the function of g of x, where x and y are not independent, where x and y are not independent. That means a change in x will affect z directly through the function f and indirectly through the function g. That means the change in x, a change in x, the change in x will affect z directly through the function f and indirectly through rho g. Yeah, this can be illustrated like here. Look at it here. X function. This is function of g, y, function f gives z. This is the function of y, f. Therefore, you can say dz by dx equal zx partial derivative with respect to x plus partial derivative with respect to y into dy by dx. Next one, implicit and inverse function rules. Before that, we'll do some example problem. Look at here, for alternatively equal to dz, we have already. Dz is equal zx dx plus zy dy divide throughout by dx. Dx gives dz by dx equal zx dx by dx plus zy dy by dx. Yeah, both are dx. So which is equal, therefore dx equal dz. It equal zx plus zy dy by dx into dx. Next one, implicit and inverse function rule. We'll do an example problem. For example, z is f of x comma y, which is equal 6x cubed 7y. How to find total derivatives? Here, look at where g of x equal 4x square plus 3x plus 8. Then we will start now. Dz by dx equal zx plus zy dy by dx, which is zx equal to, with respect to x, partial derivative with respect to x is 18x square. 18x square plus zy. Zy is before that we'll go first zx. Zx equal 18x square and zy partial derivative with respect to y is 7, and dy by dx is 8x plus 3. Here we have to differentiate here because it is only in terms of x. So dy by dx is 8x plus 3. Now we substitute in this. Therefore dz by dx zx is 18x square plus zy is 7 and dy by dx is 8x plus 3 equal 18x square plus 56x plus 21. This is the dz by dx. Next one, implicit and inverse function rule. Here y equal f of x, express y explicitly. Express y explicitly in terms of x. But some function is not expressible as explicitly. Suppose a function, another function, f of x comma y equals 0 does not express y explicitly in terms of in terms of x and x of x and are called implicit function. That means, therefore, by differentiation, you can say f x dx plus fy dy equal 0. From this, we can say dy by dx equal minus fx minus r plus of fy. Then this is further equal minus 1 over fy by fx. Now, for example, implicit function, that is, that we can say example f of x f of comma is 3x power 4 minus 7 y power 5 minus 86 minus 85. Look at here. Here This is implicit function because it's together, x and y is together in this. Now, then I have to find, look at here, dy by dx. dy by dx, the formula is minus fx over fy, which is equal. Here, with respect to x, partial derivative with respect to x of this function is 12 x cube. Then this will not come because it's this is y terms and this is a constant over fy minus, the rule is minus. Then with respect to y is 35 minus 35 y power 4 because phi is also 35. Then this gives minus minus plus 12 by 35 x cube over y power 4. Next example, find the derivative. Find the derivative for the inverse of the following. Or the inverse of the following. That is q, the function q equal 40 minus 2p. Here, where now here, then we can start the problem. dp by dq, dp by dq equals 1 over dq by dp, which is equal 1 over differentiation of 40 minus 2p is minus 2. Therefore, dp by dq equal minus half. Hence, solved. So far we discussed about differentials and total differentials, partial differentials and implicit functions. We have done. Please subscribe our YouTube channel.